Suppose we have a function f of x. And if we take the derivative, we would end up getting f prime of x. So I could call this, some function uppercase f of x. If I take the derivative of the uppercase f of x, I should get the function lowercase f of x. What does it mean? All this means is if I take a derivative, I can do an operation in reverse. That operation is what we call integral.
So an integral is going from a derivative to its original.
To the original function. So integration would move the derivative back to the original function. The way we define it, well, an antiderivative is one whose derivative will give you the original function, f of x. Anytime we have an antiderivative, I'll call it the constant of integration. Why? Well, let's see. If I start with f of x equals cosine x. Yes, the derivative of this particular function, cosine x, is negative sine x. So if you take negative sine x and integrate, that's the integral symbol, you'll get cosine x. Here is the catch. Well, I have the antiderivative. I take the derivative to get, negative sine x, which is the original function. But this answer is not unique in the sense, if I add 4, I'll still, yes.
I was gonna say, you wouldn't know, like, let's say you started from sin x, you'd have to do plus c. Because
Exactly, because I wouldn't know. I could have anything over here, plus 4, plus 10, plus 15, plus 1,000, all of them would give you the exact same answer. Which is why, when we integrate, we throw in a constant c, that is what we call the constant of integration. I want you to come up with a function, uppercase f of x, so that when you take the derivative of uppercase f of x, you get this. Because that's the definition of an antiderivative. If you take the derivative of uppercase f of x, you get this. So, we're going to do this by trial and error, but there is a proper way to do it. Let's see, I'm going to start with 4. If I took the derivative of 4, will I get that function? No. Okay. X squared? No, because the a derivative of x squared
Two
is
x,
4x.
2x squared.
2x squared.
Wait, so is capital F supposed to be derivative?
It's the answer.
Antiderivative.
Mhm.
So why exactly do you have one instead of a lowercase f and one instead of a capital F?
Because this is an antiderivative.
Oh, so the antiderivative, sorry, I didn't mean derivative.
So
So,
that would be
plus
7,
the-
7. Yeah.
Very good. So plus 7x. And plus c.
Oh,
Because we want it in general form, we don't have a unique condition. So if I take the derivative of f of x, uppercase f of x, I get the original function. Good.
Integrals is effectively taking the derivative of the integral and give the original equation, that's what you're saying.
If you take the derivative of the antiderivative, you get the original function. It is a very convoluted way of thinking. But when I do integrals, it will make sense. I'm doing it this way because this is how the book starts. Antiderivatives. Again, we're going to do this by trial and error. Well, I need some function so that when I differentiate, I get f of x. Good. Well, what should that function be? How about x cubed? Will it work? No.
X squared root.
X squared, will it work?
Would it be 1/4 and then cube root?
Here, yeah.
Yeah, like
That's what I
the
was
cube, because like 4 times 1/4 is 1, and then when you do the.
So 1/4,
And then 4 on the top.
is it right?
Yep.
Because if you take the derivative, you will get 1/4 times 4 x cubed. Correct? The therefores will get cancelled and you'd have x cubed. So that works. How about the next one?
Minus 3x squared.
Clearly, I've got x squared, which means I've got to start with x cubed.
Yeah.
If I take the derivative of x cubed, will I get 3x squared?
Yeah.
What is the derivative of x cubed? 3x squared. So x cubed. Good. Lastly, I've got x there. What should go in the last step?
1/2 x squared.
1/2 x squared. Why is that, Jay?
1/2 times 2 is 1, and then when you take the derivative, it's 1.
So when you take the derivative of x squared, you'll get 2x. The 2.5 will get cancelled, so you get x back. Are we done yet?
Plus C.
Plus.
So I've got to come up with some function so that when I take its derivative, I get x minus 5 squared. Well, some of you foiled and then did it. It's fine. I'm going to be special. X minus 5 cubed by itself, would it give you x minus 5 squared? No. So what should I do to this function so that I get
Multiplied by 1/3.
multiplied by 1/3? In which case, if I take the derivative, 3 is going to come to the front, 3's will get cancelled, x minus 5 squared.
Yep, and then we see rule as well, that you just have time.
Oh.
So as I walk around, you know, there are people who did 2 raised 3 over 2 plus. Well, root 2 is a constant. If I want to get a constant and I take the derivative, all I need is 2 root 2 multiplied by x. Yes.
Oh
My thoughts exactly. I read geometry.
Oh my god.
Exactly. How about the next one?
And wait, okay, the x wouldn't be in the root.
Yeah, it will not be in the root, outside. How about the next one?
E to the third power, so. E to the third plus c.
Oh,
E to the third times x plus c.
and why is that? Because e raised 3 is also a constant. Quotient rule. Rewrite it how?
So you choose the square root of t and so t raised 1/2.
Okay, good start. What next?
If you make it a negative 1/2, it goes on the top.
I.
Wouldn't it be nicer like that?
What would you do after that?
Quotient.
What's up with you and quotient?
I mean, a quotient product rule.
We're not taking the derivative of this. We have to come up with the function. So when I take the derivative
Oh,
of that
you just add powers then.
Figure out what we can do, figure out what we can do each of those. And
divide each by t raised 1/2. And why is that the case? Because we have a common denominator, so I could divide each term by the common denominator. Now I can move t raised 1/2 to the numerator. T raised minus 1/2. What happens here? You subtract the powers, 1 minus half. Next.
Yeah.
Good. Are we done yet? No, we just rewrote the problem. So we have to come up with the antiderivative so that when you take its derivative, you get that. What should be? Well, how about t raised 1/2? Right? What is the derivative of t raised 1/2? We can do this on the side.
1/2 square root of 2t.
That's true, but I can write it this way also. I agree with you, but for the sake of this problem. So if I take the derivative of t raised 1/2, I'll get 1/2 t raised -2. But what do I need? I simply need that. What should we do?
Put a 1/2.
What's 1/2? 2.
No.
Oh no, I don't. Enlighten me.
Because the twos then cancel. The twos will then cancel.
Exactly. So if I took the derivative, the 2's will get cancelled. I get t raised -1/2. Moving on to the next. what should I pick? The power must decrease by 1 from something, so what should that power be? 3/2. If I took the derivative of t raised 3/2, what will I get? I will get 3/2 raised 1/2. Correct? 3/2 minus 1. But all I need is t raised 1/2. What should I do? All I need is t raised 1 multiplied by 2/3, right? So if I wrote it as 2/3 times t raised 3/2, when I take its derivative, I'm going to get that. Good. The last case. Where should we start?
5/2/5. 2/5 at the very end.
We know that if we take the derivative of t raised 5/2, we will get 5/2 times t raised 3/2. But all I need is t raised 3/2. So if I did 2/5 t raised 5/2, I'll end up getting t raised 3/2. Does that make sense?
I thought that was for a second, I heard the.
So the plus C will show up, and the only time we wouldn't put a plus C is when we do something called a definite interval. I believe that is hard for
Oh, could there be another answer? Could there be another answer? That would be right, or is that the only?
that's the only one. Now, you can have infinitely many answers by changing something. But the only thing will change is it. The rest will remain the same.
Because I got c plus 1/2 times c squared plus 1/3 times k cubed plus 2c raised 1/2 plus
What's it?
c plus 1/2 c squared plus 1/3 times plus 2
Plus C?
no, just plus 2t over 1/2 raised 1/2 plus
Okay. Let's see. I could start here and just stop.
It's would be equal to 1.
Derivative of t is 1, right? Is there a 1?
the thing I did wrong, I think, was just like put the square root of t above over there, and I did c and t raised.
And then distributed the t raised to.
Well, I just added, I forgot to multiply.
Ah, I see.
So,
Oh, that makes sense.
so why did you pop up the t in 1/2?
So, first step, split it up. Yes.
Yeah.
Those two will go away, so I have 3. What do we do over there? Well, t cubed, t raised 4. I can write this as 1/t. Or t raised -1, 1 and 6. Good. And that's what we have. So if I take the derivative of some term here, I should get. So what should go?
Oh,
What?
Yeah, so
3T. What should go here? What?
ln of t.
ln of t. What?
Wasn't ln of t at the very least a derivative, and that would be 1 over t.
Exactly. There is only one function whose derivative would result in 1 over t, and that is ln of t.
Yeah, for some reason before, for some reason, I was like t squared. I have no idea why.
Right? So no other function is going to give you a t raised -1 when you take the derivative. How about the last one?
If you'd like an attempt at some to fail, it was at the very least, I tried -6 times t to the
Wouldn't it be
negative first power.
Okay, negative first power. Okay, what else?
Because then at the very least, well, it was -6, that way, when you, at the very least, of the
So we've
derivative.
got to put a -6.
Yeah.
So because of that, at the very least, you would then do -1 there, getting t to the -2nd power, and then you would bring the -1 to the front, meaning that you would have -6 times -1 times t to the -2nd power.
So, got to come up with a function.
So change rules again.
When I take the derivative, it resulted in f of x. So,
Oh, I forgot the plus.
what function, when you take the derivative, will give you secant squared x and tangent of x? Which function, when you take the derivative, will give you sin x? Negative cosine.
And since it's-
In this case, it is 2x.
Meaning that chain rule would cause.
When we take the derivative of this, I would end up getting positive sine 2x. But there would be another term.
Times 2.
Minus derivative would be sine 2x. Are we done? No,
It'd be plus sign.
times 2. So technically, when I take the derivative of minus cosine 2x, I will get -2 sine 2x.
Wouldn't it be
Sure,
positive?
it'd be positive.
So I have to divide by 2. Does that make sense? You could do something like this and just divide by 2 on both sides. Ready? So the purpose of putting a constant of integration is that the answer is not unique. If I have both of them, when you take the derivative, will give you the exact same answer, negative sine x, right? But if I introduce a condition, that's the condition, then my answer will be unique. There is only one function which will satisfy this condition. So first off, we need to come up with f of x, so that when you take the derivative, it gives you that. So what should go for?
X to the fifth minus 1/2 x to the fourth.
X to the fifth minus
1/2 x to the fourth.
Plus 4. Plus
Good.
Plus 4.
Plus 4.
plus
Yes.
4.
No, plus 4.
You would have to input something and then like, when you put 0.
Yeah, I'm going to get there. Give me a second. So that is our function. So plus c. So c by itself will not satisfy that condition. So if I find the value of c, then I'll have a function that is unique to this problem. How do we find that c? plug in 0. If I plug in 0, 0 raised 5 minus 1/2 0 raised 4 cos c.
And it would have to equal.
Given in a problem that that value is 4,
Or would have to equal 6. Yep.
so the value of the constant is c. So in this problem, there is only one antiderivative. And that antiderivative is 5x raised 4 minus 2x cubed plus 4.
Wait, what in it? You wrote the.
You wrote the
You wrote
original equation.
the derivative. I'm confused.
No, thanks. X raised 5 minus 1/2 x raised 4 plus 4. Not too exciting. So we can come up with a unique function if I have a condition such as that.
That's supposed to be X squared.
Oh, there, that's going to be 3x squared. So now we have
Mhm.
that 2, or do I guess also sorry, this could become the x or the first down. Basically, the integral that leads to f of x, or not f of x. but-
Yes, what's the next one?
I just want to make sure.
It's numbered, it's fine.
You have a sequence, so this is the second derivative. So when you go from here to there, for you to get C, what should you do? So back in the beginning of the semester, we get x, so C times x, and then you'll have another constant. E. Or C1, it's entirely up to you. Yeah, the second derivative is the first. And we start with, yes. Yes, that is correct. Because.
Here we go, just plus.
I mean, multiple choice answer something.
This is the equation.
Just-
Should
Because
be
remember,
C
it's not
times
only
X.
plus c though.
Okay.
So we're given a power.
No, it's plus
Plus one, plus two, plus one. But it's gonna turn out to be just.
Yes.
None of those things.
This I
And then
can do.
you.
What we're doing before.
So, let's see.
Well, technically, they're all constant, don't get me wrong.
I've got something here, when I take the derivative, it should give me 20x cubed. So what should go up there? 5 times x raised 4. When I take the derivative, I will get 20x cubed. What should go there? 4x raised 3. When I take the derivative, I will get 12x squared. What should be the next one? When I take the derivative, I will get 6x. But I've got to put a constant here, right? So I'm going to put C.
I know the second one is just x the fifth, x the fourth.
I've got to go one more step. So I need to get 5 times x raised 4. So what should be here? X raised 5. There. Now, I want C. So what should be here? C times x.
I love it is.
But then I need a constant there also.
Oh.
So we want to find the original function, but what is given to us is the second derivative.
Okay.
Before you guys start this problem, do you believe that this function, whatever that I'm about to find, will be unique?
Yes,
Why?
because you're giving us a point.
There are two conditions, right? So when I use those conditions, I'm going to get a unique solution. So, I have to come up with a function so that when I take the derivative, I get sin x. So what you get there?
Yep, so almost correct. Let's go.
Yes. Then I have to come up with a function here so that when I take the derivative, I get cosine x. So sin. I need the constant c. Now, I need a function here so that when I take the derivative, I get minus cosine x. So what should do that? I need to come up with a function here so that when I take the derivative, I get sin x. So what should get that?
I'm gonna change that. I sure did.
Plus C.
I need something here so that when I take the derivative, I get c.
Plus
Yes. Plus B.
I want to say that.
Now, you can call it C1, C2, CD, A, B, C, D, doesn't matter. Now, since the conditions are given, the final function that we're about to find is unique. So, first step, we could solve for C, then we could solve for D. F prime of 0 is 4. That is f prime, plug in 0. 4 equals minus cosine 0
Basically, a +1 to both sides.
plus sine 0 plus c. What is cosine 0? Negative 1.
Oh, one.
Cosine 0.
One.
1 was negative.
There's a negative cosine.
That wasn't the question. My question was, what is cosine 0? Do we really have to do this every single time? So, move that negative 1 to the other side, we get c to be 5.
Yeah.
Now we have to find d.
We're just going to follow the same form.
So, should we plug in the value of c before we find d?
Yes.
Yes.
That's pretty so. It's irrelevant, but still.
So, f of x is negative sine x
Five X. Zero.
minus cosine x plus c is 5 plus d. Plug in 0. F of 0 given in the problem 3 minus sine 0 minus cosine 0 plus 5 times 0, 0. Yes. So 3 would equal to 0. What is cosine 0? 1, and then there's a negative. Negative 1 plus 0 plus d. What is the value of d?
4.
4.
Here we go.
So our original function so you could get that answer, but how can you be sure that you have the correct answer? James?
Well, I was gonna say find the second derivative again.
Yeah, just take the derivative twice, you will get the original problem, right? If you don't get this, then you messed up. Good. So. Antiderivatives are related to integrals. Which is why we did 4.9. So integrals will start with the area problem and distance problem. And that's what I'll do next time. If you have questions, talk to me. If not,